Hello and welcome to this webinar, Developing and Scaling AI Agents. I think we're just waiting for a couple more people to join. Yeah, we're very happy to have you here today. So yeah, let's start by introducing ourselves. My name is Cheryl Hodgkinson. I'm CPO at Couts AI. I've been with the company for over 6 years now, and as Chief Product Officer, it is my task to follow latest AI trends and implement those in our platform to create value for our customers. And I'm joined here today by my colleague Jan Strunk.
Yeah, hello everybody. I've also been at Couts for 5 years now, and I'm currently the head of the AI team, which deals with all things having to do with generative AI and large language models.
Okay, so let's start by giving you a bit of information about Couts AI for those of you who don't know us yet. So we have developed a platform, Couts AI Studio, that allows companies to build chatbots and AI assistants for their employees and also for their customers. Our platform is no code, so it's very easy to use. It's open. We are technology agnostic, so we integrate all of the latest technology into our platform to just keep up with the current speed of implementation. And then we have a high degree of transparency and controllability in our platform because we believe this is key to implementing AI in your company. So what are you in for today? So Gartner, among others, names agentic AI one of the top strategic tech trends for 2025. So what we thought we'd do is get you up to speed for 2025 by introducing agentic AI to you, giving you a technology deep dive on what this means, what this entails, so you know what to expect. Then give you a use case demo to give you an idea of how agentic AI can be used in your company, what use cases there are, and then also giving you an overview of important implementation factors that you should consider when you want to introduce agentic AI in your company. So without further ado, I'm going to hand over to Jan for the technology deep dive.
Okay, thank you, Cheryl. So today, when you encounter generative AI-powered chatbots, you usually typically encounter so-called RAG chatbots, which RAG stands for Retrieval Augmented Generation. Those are chatbots that can answer a user's question based on a specific data store or database that they have. This works as follows. The user asks a question, and then a retrieval is done on this data store, usually using vector search, and relevant text chunks are identified and collected, and then combined with instructions which are called a prompt, and then handed on to a large language model, which will then hopefully generate a coherent answer based on this information that was gathered before. And this answer will then be presented to the user. This works well for external applications such as customer support. If you have a customer support bot that can answer frequent questions that customers have about your company or products. It also works well for internal knowledge management bots, where you enable the employees, for example, of your company to tap into a vast number of documents and databases that you have in your company to gain access to all that knowledge that is collected there. These kind of simple RAG chatbots also do have their limitations, and that is also part of their design. It's actually a feature. So if you want to provide such a chatbot, you usually don't want it to be too creative. You don't want it to answer based on the knowledge that is encoded in the LLM, in the large language model itself, usually. So, for example, it could answer about products of your competitors like that. So you want to restrict it to only answer the question of the user based on the data that you have provided to this chatbot. And also you don't want it to hallucinate. So you want the answers to be truthful and have a connection to reality. And therefore the instructions for these chatbots are usually relatively strict. They say only answer based on the information that was retrieved from your data store, and otherwise say, I don't know. So in case of customer support, for example, if you ask about what products do you offer, it would probably come up with a short list of products, but it won't have like a strategic approach to presenting the products that you have like a human employee would have. So it might actually suggest to hand off to a human colleague. So how can we improve on that? So one way is to give these kinds of chatbots more agency, and then also maybe call them agents. So that is done with so-called tool use. Such agents can not only answer questions and provide information, they can also carry out additional actions, such as, for example, sending an email, putting items in the shopping cart, or generating a report based on a database. So they provide process support. You can also go one step further and use multiple agents combined in teams, which then can be even more autonomous and make decisions amongst themselves on how to proceed to reach the goal, to do the task that is required. They can think about how to interact with the user, what actions to perform, without that needing to be encoded in your program code. So that is more autonomous processing. If we look at just one AI agent and the components and functionalities that it usually needs, since we're dealing with generative AI, you usually have a large language model that you have access to. And here it might actually matter what provider and what model you use. Certain models may be suitable for different tasks. So if you just want to have small talk, you could have a very quick and cost-effective small model maybe. If you want to generate SQL queries to access a database, you maybe need a model that is capable of doing that, a more advanced model or a specifically fine-tuned model for this task. And of course, you also have instructions. So the agent needs to know its goals and how to achieve those goals, the steps that it should take, the strategy it should use. And it could also have a list of tools that it might use to perform certain actions. Sometimes it's also useful that this specific agent has access to specific data. So for example, in the case of an insurance company, you could imagine that there's a product advice agent, and this would need access to data about the current insurance policies that are on offer. But it shouldn't have access to outdated insurance policies, so as not to be confused, for example, and it probably doesn't need access to further information about the company as a whole. Usually, such agents also have memory, and that is both memory of what they themselves have already done, the actions they have taken, and so on so far, and also memory of the conversation they have had with the user, if they are directly in contact with the user. And they may even have access to additional data, for example, about the user. If the user is logged in, they may have information about their account and so on. And such AI agents can then autonomously plan how to achieve the goal and task that they have to achieve. They can make decisions how to interact with the user, ask questions back to the user, and what actions to carry out. So if we have multiple agents that we want to combine, then two concepts from basic economics and also maybe from software architecture come into play, namely division of labor and specialization. So why would you want to have multiple agents? Two scenarios are here. One is maybe you have a complex task that can be divided into subtasks. For example, this RAG, retrieval augmented generation, you could also divide into subtasks. You could have one agent that does document retrieval, that actually retrieves data from documents. You could have an additional agent that retrieves data from databases using SQL queries, for example. You could then have an agent that generates an answer based on the gathered data. And maybe you could even have an agent that evaluates that answer, whether it doesn't violate any policies, whether it should be censored for some reason, whether it's how secure or how sure the answer is, whether it's really answering the user's request, and so on. This is one example. You could also have teams of agents that are more specialized, but still work together, for example, inside one chatbot. For example, if you have a customer support chatbot, you could have different agents. One agent that answers general questions about the company and products. That would be, for example, be a RAG agent. You could have this kind of product advisor agent that has specific knowledge about, for example, insurance policies and can recommend them to based on questions to the user, actually. Or you could have, if a user wants to file an insurance claim, for example, you could have a claims collection agent that knows what data it needs to collect from the user to actually then file that claim by performing some kind of action. And the reason why you want to have this division of labor is the same as in normal economics. It's easier to instruct the individual agents or workers. And it's also the quality goes up because they aren't confused by a long list of different tasks and data that they can use and perform. Each one is specialized, and therefore the quality of each agent usually improves. Okay, so how can these agents work together in teams? There are several architectures, agentic architectures that one could imagine. There's a more centralized one where you have a special agent, which is usually called orchestrator, that controls the flow of information and tasks between these different agents. That's also the architecture that we mostly currently use at Couts, because we are still mostly based on a user interaction framework in a chatbot where we react to user input. And the orchestrator then decides, does the user want to know something general? Then it hands off to the RAG agent. Does the user want to file an insurance claim? Then it hands off control to the insurance claim agent, and so on. But you could also imagine more decentralized agent teams that basically just work beside each other in parallel on different subtasks, and they interact directly amongst each other and hand off data and control between themselves. So I want to get back to tool use for a second again, because we have talked about how agents can carry out specific actions. And I would argue that there are several degrees of tool use. Maybe the standard one at the moment is function calling, where you have predefined functions in the code, in your code base actually, that the agent knows about, and it knows how to call these functions. You can go a step further if you allow these functions to actually access the external world, such as external APIs or databases to gather data. And you can even be more creative and more adventurous if you actually let the agent generate code in a programming language, such as, for example, Python, and then execute that code in a sandboxed environment to be, of course, there are security issues and so on, but of course, it's the most flexible approach, but also experimental at the moment, I would say. So my final slide is about how would you develop these kinds of AI agents or teams. You can, of course, do proprietary development. The advantage is, of course, it's not really difficult for simple use cases. And it's very flexible, of course. You have the control. You can define exactly how these agents should behave, how they interact, how the control flow is, and so on. The disadvantage is, of course, that you're not really tapping into this developing ecology of agentic frameworks that is developing. And also you have to do things like work on scaling these agents, the number of agents, how they can work together, and so on. There are also existing frameworks for agentic AI, such as Swarm by OpenAI, which is very easy and intuitive, but is also not recommended for use in production by OpenAI. It's more like a proof of concept, basically. There are also more established frameworks like LangChain and its specific agentic framework LangGraph by LangChain, where you have many predefined agents and frameworks. You have complex underlying models with high functionality and control, but Yeah, it's also complex. You have a steep learning curve. You really have to learn a lot to use it. And sometimes you need an agent that needs to do something that exactly these predefined models can't do. And then it's somewhat challenging to modify these frameworks. There are also other frameworks like Crew AI, which are more easy and intuitive, but then again, you may have limited configurability and control. So at Couts currently, we actually use a combination of proprietary development for specific agents for very specific tasks, and also for the general control flow within our chatbots, basically. But we do use, for example, LangChain for specific agents if they work well for us. And we'll keep an eye out, of course, on this ecology of agentic frameworks, and we'll integrate things that seem useful and interesting to us. So with that, I'll hand over to Cheryl, who will give you a more practical outlook and examples how we use agentic AI at Couts.
Okay, thank you very much, Jan, for that concise overview. So for my demo today, I've selected a local energy provider chatbot as an example. So this is a demo for Stadtwerke Musterstadt. You could imagine this chatbot on the website for Stadtwerke Musterstadt, and this chatbot is targeted towards customers. So what I'm going to show you that within one conversation, several agents within that chatbot are targeted, selected by the orchestrator to fulfill different tasks and different customer needs. So let's start. So first off, the customer asks just regular question. I already have a contract with another energy provider. Can I switch contracts? So this is a regular FAQ. So just a question, information retrieval. So the orchestrator would select a RAG agent to answer this question, which would then retrieve relevant information and generate an answer based on that, and give sources, of course, so the user can see where that answer is from. So, so far so good. This is a very easy one-shot interaction that has a restrictive use case. So let's go beyond that. Now the user says, well, that sounds great. Which one of those tariffs would you recommend to me? So now we go into a more complex task, which is product advisory. For that, the agent might need some further information about the user to get to know their preferences, etc. And also this is a more creative task, if you will, that goes beyond retrieving information and just displaying them. So now the orchestrator would select a product advisory agent that fulfills that specific task. So first, that agent would ask a question. In this case, do you want your electricity to be eco-friendly or from renewable sources? Just to get to know the user's preferences and what they want. So in this case, the user says, well, I want eco-friendly. That sounds good. And then we get the next question, which is, would you prefer 12-month contract or the flexibility to cancel every month? So another question about the user's preferences. So now the user is given that kind of information, and based on the answers that were given by the user, the agent now gives a recommendation. They say, okay, Ökostrom Active seems to be the most suitable tariff for your needs, and recommends that to the user. So next up, the user says, well, that sounds good. How much does that cost? And for that kind of interaction, again, we need a specialized agent that can conform that. So first, the agent, again, needs some more information. So for energy costs, that would typically be something like, okay, I need to know how many people live in your household to kind of get an estimation on what your usage is. So it first asks that piece of information that the user can then give, in this case 2. And then the agent with that information can conduct a more complex task again, which is a price calculation. So this is a typical use case for tool usage. So with the information, a calculation will be conducted with a predefined function or via API call. You could also, of course, ask an LLM to perform those tasks, but especially in production, you might want some more controllability about how the cost is calculated. So now I have information on how much the tariff that is recommended to me costs and lined out for me. So next up, I say, well, that sounds great. Where can I sign up for that contract? So here again, we start another process, which is of signing up. Again, this specialized agent, which is selected by the orchestrator, first needs to know some information about the user, which in this case is, okay, when would you like to begin the contract? Which the user then gives the chatbot in 2 months. And then the chatbot says, well, great, okay, now give me your email address. This is also to verify the user's identity and also to send it the contract afterwards. So great, now the agent was able to create a contract, in this case, basically by filling out the information that was gathered within the conversation and then send it to the user, who can then conduct the task or can continue with signing up to the contract with the information that was sent via email. So a very short and very natural sounding conversation to the end user, which involves in total 4 agents. And let me show you how that works in the background in the AI Studio. So for that, I'm just going to switch into our AI Studio. So here you can see our AI Studio, which is the platform that your company can design chatbots for. As you can see, the AI Studio is built to support the entire lifecycle of an AI agent, so from configuration to content, testing, and analytics. But I think what is most interesting today is the agent management. As I just pointed out, 4 agents were at work in this conversation. One is a default RAG agent, which was used to retrieve information and answer one-shot questions. And then also we have a product advisor here. So I didn't log in beforehand, so give me a quick second to sign up here again. There we go. So in the product advisor and any other agent, we have the same components. One is a trigger that tells the orchestrator when this agent should become active. In this case, when the user wants a new energy contract and wants a recommendation about that contract. Then the second thing that you need is instructions. In this case, this consists of a basic prompt that is overall for the entire chatbot. So this would contain information on the role, the personality, etc., something that is valid for all agents. And then I have a custom prompt, specialized prompt for this specific agent, which instructs it to give a product recommendation to the user. And then also it has data that it can use, very specialized data. In this case, for a product recommendation, this would typically be a product table, a very concise list of products that has all of the product names and the key features of the products that the agent can use to then decide on a recommendation for the user. And if you want a bit more control on which questions are asked to the user, you can also provide a list of questions that should be asked. And this is how the agent can conduct that. Let's have another look here at, for instance, the contract creator. Again, here I have a trigger that tells the orchestrator when to select this agent. I have a custom prompt for this agent that tells it to collect data and then use a tool to conduct a task. So here the data looks a bit different. It's a bit more structured because at first it needs to collect data in a very structured form. Please note that in the conversation that you've just seen, the agent did not ask all of those 5 questions, but only 2 of those, simply because it already had those questions answered within the conversation. So, for instance, which energy tariff was already determined in the conversation with the product advisor. So it only asked, okay, when do you want to begin the contract? And then what is your email address to retrieve the variable email address that is then needed. Once all of that information is collected, it is instructed to use the tool contract creation and send it via mail. So this is how you can very easily design an agent team for your chatbot. Mind you, 4 agents are already quite a lot. It's very complex. complex interaction. You might also design this differently, combine different tasks in different agents or split it up more. If you go far beyond that, we would recommend going the chatbot route as well. So this is all within one chatbot. You can also differentiate different tasks within different chatbots and go from there and scale from there. So this is a quick overview on how we handle this in our platform. Let me return to the slides. So after this demo, where are we heading from here? So agentive AI and agent teams allow you to use AI in more complex ways than RAG had. So already for employees, knowledge management was one of the first use cases for AI. We've noticed, or we think that with agentive AI, you can go further. So that's why we are developing Cards AI Workplace. This is a new chat interface that goes beyond the chat interface that you've just seen, which we would still have on on your web page, etc. But you would have a login for a workplace for your employees where they can perform tasks to boost their productivity. One use case that we frequently hear about is the use of SQL agents for research. So basically tapping into the databases, conducting research on, for instance, website visitors, and then making decisions from there. Other use cases that we are confronted with daily are things like creating documents, writing texts, etc., and also classifying, summarizing, and answering emails. So those will all be integrated into the AI Workplace coming Q1 2025. So wrapping up, implementing agentic AI, what should you look out for? The first thing you should do is select a technology agnostic platform to implement this or to introduce this into your company, simply because agentic AI is still evolving and it will evolve rapidly in 2025. So make sure that you select a platform like AI Studio that makes that possible to use different kinds of technologies. Then implement multi-agent frameworks, so make sure to select that, simply to break down complex tasks or to distribute tasks among different agents to be able to go beyond the limits of one small convoluted agent that then might not be as precise in what it does. And then last but not least, tool use is central to making agentic AI actually actionable. It needs to be able to perform tasks for you in order to be more useful. Of course, this has its limits and it should be controlled in some sort of way. So for instance, with a human in the loop or with very defined and very restricted possibilities. So basically, for instance, only read but not write, etc., to work with that. So those are the three takeaways I would like you to take away from today. And yeah, that's it for our webinar. Thank you very much for joining us today. If you found this webinar interesting, be sure to follow Cards AI on LinkedIn. We post regular updates on advancements in AI, also success stories from our customers that give you an idea on how you could implement AI in your company. And yeah, we're looking forward to seeing you also in 2025. Thank you very much for your attention. So we see a question here. How do you handle RAG for really large data, or is it just separation for domain-specific agents to inject a limited set of data and an orchestrator? Jan, would you like to take that question?
Yeah, I mean, in the AI Studio, we haven't focused on that yet, but you can integrate different data sources, for example, from your website, from documents you have, and maybe things like SharePoint too. So you can have a lot of data. You could, of course, have different RAG agents too. So you could say, depending, maybe the orchestrator can already decide what this question is about and could then basically make search and retrieval more efficient by handing off to one specialized agent that has access to a specific data store, I would say. Of course, yeah, if you are a very large customer which has a lot of data, then probably you would need your own environment, for example, at Couts. So we have enough resources there. For very small customers, we also have multi-client environments where several customers basically share one larger environment. So there are different ways how to deal with these really large data sets. Yeah, I hope this has answered the question a little bit.
Okay, thank you so much, Jan. Are there further questions? Let's wait another minute there. Otherwise, feel free to type your questions in the chat and also in the comments. We will make sure to answer them later. And yeah, that's it for our today's webinar. Thank you very much for joining us. And again, please join us and follow Couts AI at LinkedIn. Bye.
Thank you very much. Goodbye.